functions f and g are defined for all real values of x by f of x, which is equal to 4x squared minus c, g of x is equal to 2x plus k, where c and k are positive constants. It is given that the g inverse of 3k plus 1 is equal to c, so that g f of x is equal to 8x squared minus k minus 1. Now, when they say that g f of x, we are supposed to compose f into the g. Okay, we are writing f, we replace here, this f of x will replace the x here. Okay, so we shall write g f of x is going to be equal to 2x, I mean 2, then where there is x, I'm going to put f of x, okay, then plus the k. Now, what is f of x? So we shall put 2 into 4x squared minus c, then plus the k. When you open the brackets, this will be 8x squared minus 2c, then plus k. In this expression here, there is no c, so we have to look for the value of c. Now, we come to this one here. If you have g inverse of 3k plus 1, which is equal to c, I can take the g this side, and then I say this is 3k plus 1, which is equal to g of c. So 3k plus 1 is going to be equal to g of c, where there is x, you put the c. Okay, so that will be 2c, then plus k. Now, I am making c the subject of the formula, so I can bring the k this side. We can have 3k, then plus 1, then minus k. That will be equal to 2c. Then I can divide through by 2. But since here there is 2c, I just leave it like that. So my 2c is going to be equal to 3k minus k. That will be 2k, then plus 1. So I'll get this one here, and then I substitute it here. Okay, so we are going to have 8x squared minus the 2c is 2k plus 1. You put it in brackets to avoid errors, because you can see that that is a minus, so it affects everything inside here. Then we shall put plus k. So when you open the brackets, that is 8x squared minus 2k minus 1, then plus k. Minus 2 plus 1, that one gives us a minus 1. So that means g f of x is going to be equal to 8x squared minus k minus 1 as required. Part B, the curve with equation y is equal to 8x squared minus k minus 1 is transformed to the curve with the equation y is equal to h of x by the following sequence of transformations. So we have translation of 2, 3, stretch in the y direction by the scale factor k, and then reflection in x-axis. Find the expression of for h of x in terms of x and k. Now, when we are putting this one here into where this one is, it will be a minus. So I can say y1 is going to be equal to 8. Okay, in fact, we are going to have something like this. For the first one, for the translation, I will have y. All of these ones, when I put x, with these two where x is, so we are moving 2, 3, it is moving this way to the right, because that is when x is positive, and also up here. Okay, 3 units. Now, we are going to have, when I put also this 3, where y is, it will go there as a minus. 2 will go where x is, it will go there as a minus. So we shall have y minus 3, which is equal to 8. Then x will be transformed to x minus 2 here, squared. Then minus k minus 1, you see? And then I can take this one this side. Usually we don't write this one, we just put the 3 this side. So y is going to be equal to 8 into x minus 2 squared, then minus k then minus 1, then we shall add a 3. So meaning y is going to be equal to 8x minus 2 bracket squared, and then minus k, then plus 2. Now stretch in the y direction by factor k. That one will now be, we multiply this one by k. So y now becomes k into this whole thing here, 8x minus 2 squared minus k plus 2, like that. Okay, here we are doing stretch in the y direction, stretch in the y direction by scale factor k. Okay, here we were doing translation by vector 2, 3. Okay, now the next one is reflection in x-axis. When you reflect anything in x-axis, okay, let's say this is the point here, its x-coordinate is x, then this one is y. Then when you reflect in x-axis, this one is going to go down here. Okay, so the x-coordinate remains, but the y-coordinate changes the sign. You see that? The y-coordinate changes the sign. So that means wherever there is y, then we are going to put a negative. So the whole of it, we make it a negative. Okay, so this is what we are going to do. Now, reflection in the x-axis. So here we say y is now equal to negative f of x. Okay, the negative of that, because y has changed the sign. Okay, and then here it is y, which is equal to a f of x. You see, we are multiplying all through by that a. Actually, I'm going to write it as a k because the scale factor is given as a k. So that is k there. So meaning our h of x is going to be, put a negative everywhere, so it will be negative k into 8x minus 2 here squared, then minus k. I can even write it as plus 2 minus k, then like that. So that will be the expression for h of x in terms of x and k. Part C, the range of h is given by h of x less than or equal to 15. Now, since this one here is in the completed square format, okay, I can write it like this. H of x is equal to negative 8k, then x minus 2, if I open the brackets, okay, then k times the whole of this. We are going to have, that will be positive k squared, then minus 2k. Okay, now when I open the brackets here, remember they said k and c were positive constants. So this whole thing here, when I expand this one, I will again multiply by the negative 8k. That means the coefficient of x squared is a negative. Okay, so since the coefficient of x squared is negative, okay, this is an N-shaped curve. An N-shaped curve with a maximum what? Turning point. So we are going to have something like this. Okay, and that turning point, you just get this one equated to 0. The turning point here will be, the x coordinate is 2, and then this is the y coordinate here, which is k squared minus 2k. Now, all of these values of y are going to be less than this one here, because this is a maximum point. The rest have to be below it, okay? Now, that means range of range of this h of x is actually h of x less than or equal to, because the rest are less than or equal to this one, so less than or equal to k squared minus 2k. You see that? So this therefore implies that I'll get this 15 and I equate it to this one. So we shall have k squared minus 2k, which is equal to 15. When I bring this one here, it will be a minus. Two numbers, when I multiply them, they give me negative 15, but when I add them, they give me negative 2. That one, those two numbers, they are going to be 5 and 3. And of course, this one has to be a minus. So we have k plus 3 and then k minus 5, which is equal to what? 0. So meaning when I equate all of these ones to 0, k is going to be a negative 3 and also k is going to be a 5. And I will take k being a 5 because they said k is a positive constant. Okay. Now when we go back and we check, we see that 2c is equivalent to 2k plus 1. So I'll have c, which is equal to this 2k, then plus 1, then I divide by 2. Okay. So c is going to be 2k plus 1 over 2. We shall have 2 times 5, which is 10, plus 1, 11, divide by 2, that is 5.5. So c is going to be 5.5. Or you can write it as 11 over 2. And that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.